Hey, we're going to talk about static electricity in this video. If you were here to see this in class, it's a pretty interesting demonstration of static electricity. This is called a Van de Graaff generator. And I can explain to you how it works more in detail on the board, but basically what's happening is that there is a white belt that is rotating up and down here. It's going up to the top and back down to the bottom, and it rubs on a brush up here at the top. And that rubbing, that friction, causes electrons to preferentially be transferred from this metal bulb into the belt. And when those electrons get transferred, that means this metal ball is losing electrons, it's losing negative charges. And so it's becoming more and more positively charged. And the white belt inside is becoming more and more negatively charged. And you might hear these sounds every once in a while. That's the sound of all of that charge that's building up in these two places. At some point it reaches a point where there's no more that can be built up, and it discharges into the next or closest available thing. And you might be able to see this if you bring your hand or some object close enough. You hear the sound first, and that sound is the sound of the electrons traveling from one place to another. Right now it's from this wand into the ball because that's where the electrons want to go. They want to go toward the positive charge, but you might be able to see, hopefully, and it's shocking all the way through my body right now. I don't know if you can see that very easily. Perhaps let's bring it a little bit closer. No, it's hard to see. Well, if you were here in class, you might be able to see small arcs of electricity going from the Van de Graaff generator to my metal ball. So that's a good example of static electricity. In order to start our discussion of electricity in general, we need to start talking about static electricity, or otherwise known as electrostatics. So let's talk about that. Okay, these are your notes on electrostatics. Static electricity. Hopefully you know that the word static has the root word stat, stat, in it, which is also found in the word stationary, which means something that is not moving. And that's where we get static electricity. And I want you to know what that word means. I know when you pull clothes out of the dryer, sometimes we say that they're quote-unquote staticky. But we need to understand exactly what that means. And the word static means staying in one place. And that applies to static electricity, because static electricity, or electrostatics, is the study of electrical charges that are collected and held in one place. This little drawing of the Van de Graaff generator, you can do lots of neat fun tricks with it, like sometimes with certain people's hair, it'll make your hair stand on end because all of the electrons from your body will flow into that ball as well. And when your hair becomes positively charged, it begins to try to get as far away from itself as possible, and it will stand on end. But effectively what we did by running that belt inside of that generator, we had this belt, remember, that was running up and down, and at the top it was rubbing on a little brush. And as electrons began to be pulled off of the ball into that brush, that preferentially collected charges, positive charges, on the top of the ball. And that was static electricity. The charge is collected and it's held in one place. Some common examples of static electricity that we probably experience every day include brushing your hair with a comb. You might notice, if you have longer hair, that after you brush your hair with a comb, your hair sticks together, or it sticks to the comb. There's some form of electron transfer that goes on when you rub things together. That's static electricity. That's collecting a charge in one place. Your clothes in the dryer, if you don't put a dryer sheet in there, they'll probably stick together because as they rub together, the electrons get transferred from one to another, and that creates static electricity. It creates a collection of charges, and those charges sometimes can cause a positive and a negatively charged object to bind to each other. We'll talk about exactly how that happens in just a moment. Rub a balloon on your hair, it'll stick to your hair, or your hair will stand on end. That's also static electricity. And actually, lightning itself is a huge example of static electricity, massive static electricity. You can think of the cloud itself as a large Van de Graaff generator that accumulates lots and lots of charge and when it discharges, it does make an arc just like the one that you saw on the Van de Graaff generator, only it's much, much larger. All right, I want you to take a moment, and in your notes or on a scratch sheet of paper, I want you to jot down the answers to these 3 questions. I want you to remember from your chemistry days, what are the 3 parts of an atom, where are they located, and what are their charges? Pause the video for a minute and think about that. All right, hopefully you can remember about the nucleus of an atom, the small part in the middle. Let's make it a little bit bigger. There's a nucleus, and inside the nucleus there's 2 particles. There are neutrons, which are neutrally charged, and there are also protons, which are positively charged. Positively charged protons, neutrally charged neutrons. Makes sense, right? These are very tightly packed, very dense. Almost all of the mass of the atom comes from what's in the nucleus. Very, very tightly packed. And then we can draw what we call the outer electron shells, and I'll just draw one for our purposes, but there are electrons out here which are negatively charged, and they are theoretically, as far as we know, swirling around the nucleus sort of in a random fashion. They're moving. They don't have very much mass, but they do have a negative charge. If this atom was drawn to scale, either the electrons would be way out of the picture off your screen, or the nucleus would be so small that you probably couldn't even see it. That's how densely packed this is. But this is the picture of the electron. This is what we have going on, and we're talking about electricity, and electricity is called such because it involves the electrons. The electrons will be transferring from one place to another, and that's what creates electricity. So let's talk about these charges. There are 2 kinds of electrical charge. You can either be positively charged and negatively charged. And the way that objects get charged is that they either gain electrons or they lose electrons. Okay, if you gain electrons, electrons are negative, remember. So gaining electrons means you're becoming more negative. You're gaining a negative charge. And if you're losing electrons, that means you're losing negative charge. What it really means is that you're becoming more positive. And so that is how objects get positively charged. Hopefully you've heard this before. Remember that like charges repel and opposite charges attract. And so if you have 2 negatives, they will repel each other. 2 positively charged objects will repel each other. And a negative and a positive will actually be electronically or electrically attracted to each other. Neutral objects. For an object to be neutral, it does not mean that there are no charges in the object. What it does mean is that the number of protons and the number of electrons, or the number of positive and negative charges, are equal. They're exactly the same. Okay, and that's very important to understand. Within the atom, as we've already drawn, we know that there are positive protons, there are negative electrons, and we also know that there are neutral neutrons, which really don't play a part in this electrical process. And so the question is, how do objects become charged? Well, we already answered the question up here, but you need to capitalize on this, that they become charged by transferring electrons. Protons do not get transferred, and neutrons do not get transferred. And you'll be surprised how much of a temptation it will be to say that an object will become positively charged by gaining protons. That is not the case. Objects do not gain protons. Now, to that effect, I want to stop a minute, pause a minute, and ask you a philosophical question. Looking again at our picture of the nucleus that we drew, I want you to, or the atom, I want you to look right now at the nucleus. Protons do not get transferred because they are in the nucleus. They're inside. Not only are they inside, they are held there very, very, very tightly. Very hard to get the protons out. This nucleus is tight. It doesn't change. Protons don't leave, neutrons don't leave unless you put in a lot of energy. And that we'll talk about later on in the course. But I want you to remember what we just learned, that like charges repel. Likes repel, opposites attract. And I want you to look at the nucleus, and I ask this question: how does the nucleus stay together? It's full of a bunch of tightly packed positive charges. Those positives are not attracted to the neutrons. The neutrons hold no attraction to either electrons or protons. By all rights, this nucleus should blow apart because all of these positive charges should repel each other. Well, obviously that doesn't happen. As far as we know, atoms don't spontaneously blow apart, at least not for this reason. And so if there's a force that wants to blow this nucleus apart, that means there must be another force that is simultaneously and more stronger that's holding it together. More stronger. What a great English person I am. It's a stronger force in there that's holding it together. And science is really good at observing things and naming things that describe the observation. And we try our best to explain it, but sometimes things are really hard to explain. And this force that holds the nucleus together we'll talk about later in the course, but it is simply called the strong nuclear force. Funny, right? It's the force that holds the nucleus together, and it's really strong, so we're going to call it the strong nuclear force, but we don't really know very well how it works because, like we said, positive charges stuck together in any other way are supposed to repel each other, but in the nucleus of an atom they don't. Very, very interesting physics and philosophical question to consider.